all 13 numbers. So this is to give you an idea of how this will look like. Let's say we're gonna pick, let's say n equals 5, and we pick 1, 2, 3, 4, 5 on our first pass. And then we come back here, 9, 10, 11, 12, 13. And on our second pass, we're gonna pick 6, 7, 8, 9, 10, 11, 12, 13. So that's gonna be only 2 passes, but we'll be managing to pick 13 numbers, all of the cards. So when I think of this, I think of casework. Why? Because we essentially categorize them, and this is an important skill to note, because in those kind of problems, probability or combinations, permutations, you can do casework, but it's easier to generalize at first like this. So categorize. Like, how's the case gonna look like? Well, in this case, we're only gonna change what n is. So let's see. First case, pass 1, pass 2, n's gonna be 1 to 1 and 2 to 13. And that means that we're only picking up only 1. And then on the second pass, we're gonna be picking 2 to 13, right? So what can this look like? Well, to give you an idea, it's gonna look something like this, right? You go from left to right, but you see you pick 1, right? But then since there's no 2 to the right of 1, we go back to the left end, and we pick 2, 3, 4, 5, all consecutively up to 13, right? So how many orderings of this is possible? Well, I mean, we're basically putting 1, so we already have this sequence in a chronological order, right? We're just putting 1 where it is possible. So well, I mean, it's easier to do it this way, right? We're just gonna regard entire this thing as a letter B. I'll tell you why in a second. Wait, I think it's gonna be better if we use right, okay, B. Then we're gonna regard the one that we pick on the first pass as an A. So now we can just find a way to order 1A and 12 B's. And the way to order, and the number of ordering possible, is 13 factorial divided by 1 factorial, again divided by 12 factorial, to order 1A and 12 B's. So how's this gonna look like? Well, it's gonna look like A, it could be B. But the reason why I aligned all B, the reason why I chose to represent those 2 categories as A and B is that if you note here, the chronological order, the order and the second pass is already decided, right? So we can just regard it as the same thing. We can just regard it all B. But in fact, all B has a unique number attached to them, it's already decided. So this thing you get here will represent how many orderings possible, the number of orderings possible when you're gonna find out this whole thing, right? But as you see here, there's a problem. If you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, don't you see a problem? The problem here is that it's gonna go in one pass. And that's not allowed because the question asks for exactly 2 passes. That means that we have to minus 1. This case where it's gonna be 1 pass. Similarly, in other cases, when let's say another case, let's say there are 3 A's and 10 B's. What this is gonna look like is 1, 2, 3, 4, 5, 6 to 13. And this also has to be eliminated later. Why? Because it's gonna be only 1 pass required, and then we don't want this. And the reason why I say that it's 1, 2, 3 when A's here is that the order is already decided, right? The order is an numerically increasing order, so it's already decided. It's 1, 2, 3. If we put A here, 3 A's, it's already decided that it's gonna be 1, 2, 3 on the first pass. And if you say B here, it's already decided it's 4, 5, 6, 7, and in an increasing number order. Hopefully that makes sense. So on our first case, we got this. Now let's move on to our second case. Pass 1, pass 2, and for our second case, let's do 1 to 2 and 3 to 13. Again, we can denote all pass 1 as A's and all pass 2, all cards that are picked up and pass 2 as B's. Now, how many orderings of 2 A's and 10 B's possible? 11 B's possible. Well, that's gonna be 13 factorial divided by 2 factorial divided again by 11 factorial. But as I said here, if we do A, B, B, and then 11 B's, this is just gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? That means that we have to negative this as well. We have to minus this one case because it only requires 1 pass. So in this case, we get this one. Should we try another one? Pass 1, we do 1, 2, 3. How many ways to order 3 A's and 10 B's? 13, that's going to be 13 factorial divided by 3 factorial divided by 10 factorials negative 1. Why? Again, we have to 10 of B's, 10 B's. We have to negative this case where it's going to be 1, 2, just going to be 1, 2. Again, I tell you that it can't be 1, 3, 2, 5 like this. Why? Because then it's gonna be 1, 2, and then it's gonna come back to this 3 here, because 3's here, and that means it should come back, right? So that's gonna be another pass required, right? 1, 2 on first case, 3 on second case, and then 3, 4. Okay. 3 on second case, and then since there's no flower here, we have to go 3, 4, right? But then since there's no 5 here, we do another pass. This is gonna be messed up. So one thing to note is that this sequence, this order already decided. In order, right? So if you look at all our past cases, the first case was this one, right? And this one is just gonna be 13, choose 1, -1, right? How about the second case? Well, 13, choose 2, -1. How about third case? 13, choose 3, -1. Then how about, so let's say this continues. Then what's gonna be the last case? Well, the last case obviously is gonna be 1, 2, 12, and 13 to 13, which means only 13. So it's gonna look something like this: 1, 2, 3, up to 12, and then 13's here. So you go on first pass, you go up to here, and you pick 13 on your second pass. So how many orderings? Well, again, A and B. So 12 A's and 1 B. How many ordering is possible? That's gonna be, but again, we have to -1 because we don't want this sequence where it's just gonna be one pass, right? So again, we -1 here, and that's gonna be 13, choose 12, right? In the last case, which is gonna be our 12th, 12th is gonna be 13, choose 12, 12, -1. So in the end, we just have to compute this. But all right, if you can't think of this, you can just compute this easily. Why just change it to this, and then you can just compute whatever and then times 2 to do it easier, to do it faster. But there's a faster way, right? The faster way is to think of binomial theorem. Which states n minus r, which states this. But if we plug 1 into both A and B's, you get 2n equals just n to the power of n. N choose n. And you can easily compute this sum here by saying 13 choose 0, 13 choose 1, 13 choose 13, right? But if you notice, we don't have this and this here, but it's just 1, right? Combined, that's 2, so we minus this, and then we get 2 here. And then don't forget that we also have to -12 times. So we just have to -12, and it's going to be 2 to the power of 13, -14, which is, if you compute this, it's just gonna be, wait, let's do this. That's gonna be, and just -14, you get this number here, and that's gonna be our answer for this cool AMC question from 2022. Hope you guys enjoyed this. If you guys have any questions that you want me to solve for you, I'll make a step-by-step video in a lucid and clear explanation. Thank you, and hope you guys enjoyed this video.